Assalamualaikum and good day. I am Putri together with my group mates from 5Ls. We'll be presenting on gas chromatography and discussing 5 results obtained from the gas chromatography analysis. So this is our team. The first is Muhammad Haziq Irfan bin Rosli, Muhammad Damian Farhan bin Mazlan, Irsyad Roshaidi bin Ismail Fakurazi, Putri Batisha Izzati binti Ahmad Arafat, and Wanur Afzan binti Zainuddin. So, what is gas chromatography? Let me simplify it. Gas chromatography is an analytical technique used to separate mixture components based on their vitality and boiling points. A vaporized sample is carried by an inert gas, such as helium or nitrogen, through a column containing a liquid or solid stationary phase. When separation occurs due to their different interactions, the separated components are then detected electronically.
Next, the objective for this experiment is first to determine the retention time of n-butanol and 2-propanol. Secondly, to identify the component present in a standard mixture based on the retention times. Third, to identify the component present in an unknown sample. And lastly, to determine the effect of temperature on retention time and RS resolution.
For the methodology of this experiment, we use gas chromatography. This technique is commonly used to separate, identify, and measure compounds that can be vaporized. First, the sample is injected through the injector port, where it is immediately vaporized. A carrier gas such as helium or nitrogen then transport the vaporized sample through the column, which is placed inside an oven. The oven controls the temperature and helps achieve a better separation of the component. Inside the column, the compound in the sample move at a different speed depending on their properties. Because of this, they become separate from one another. After leaving the column, the compound reaches the detector, which records their presence. The detector sends the signal to the computer, producing a chromatogram with peaks. Each peak represents a different compound, and from the retention time and peak size, we can identify and estimate the amount of substance in the mixture.
Now I'm going to tell you about result and discussion for part 1. The result that I got is 2-propanol. The peaks observed in the gas chromatogram are influenced by the boiling point and volatility of the compounds. More volatile components elute earlier because they are vaporized more easily and spend less time interacting with the stationary phase. In this analysis, 2-propanol, which has a relatively low boiling point, elutes at a shorter retention time and produces the major peaks, indicating it is the predominant component in the sample. The size of the peak represented by its area corresponds to the amount of component present, with a larger peak area indicating the higher concentration of 2-propanol. The chromatogram shows a major peak at a retention time of approximately 2.72 minutes, corresponding to 2-propanol. A minor peak at around 3.63 min is observed, suggesting the presence of a small amount of impurity. The early elution of 2-propanol is due to lower boiling point and higher volatility. As a result, 2-propanol spends less time interacting with the stationary phase, allowing it to elute faster from the GC column. Increasing the column temperature in gas chromatography decreases retention time because compounds spend less time interacting with the stationary phase, causing peaks to elute faster, as seen in the chromatogram, where 2-propanol elutes about 2.7 minutes at 70 degrees Celsius. However, higher temperatures can reduce peak resolution because peaks move closer together and may overlap. In contrast, Decreasing the column temperature increases retention time since compounds interact more strongly with the stationary phase, shifting peaks to longer times and generally improving resolution. Two peaks may broaden, the analysis takes longer. Overall, a higher temperature gives faster but less resolved separation, while lower temperature gives slower but better resolved peaks.
Next is the result and discussion 2. The result that I got is N-butanol. The peaks are determined by the boiling point and volatility of the compounds. More volatile components elute earlier and give small peaks, while N-butanol has a higher boiling point, so it elutes later and produces the main peak. The peak size represents the amount of compound present. Next, let's take a look about the chromatogram and butanol. Show a major peak at approximately 6.04 minutes, and the standard mixture show the earlier major peak at 2.6 minutes and the second peak is 2.9 minutes. This peak was assigned to N-butanol as it has a high boiling point and lower volatility. It spends more time interacting with stationary phase before eluting from the column. What happened when we increasing and decreasing the temperature? When we increasing the column temperature, it makes N-butanol elute faster, giving shorter retention time and narrower peaks, but may reduce resolution. However, when we lowering the temperature, it increases retention time, improving resolution, but results in broader peaks and longer analysis time. That's all from me. Thank you.
Now we are looking at the chromatogram of the standard mixture. The chromatogram shows two major peaks, which represent the two components present in the mixture. The first major peak appeared earlier at approximately 2.69 minutes, and it contributes around 36.98% of the total peak area. The second major peak appeared later at around 5.9 minutes, contributing about 63.01% of the total peak area. These two peaks indicate that there are two different components with different retention time due to difference in volatility and interaction with the stationary phase. The earlier peak corresponds to the compound that is more volatile and has a lower boiling point, while the later peak corresponds to the compound that is less volatile and has a higher boiling point. In the next slide, I will compare this retention time with the chromatograms of individual standard compound to identify them. To identify the earlier peak, we compare the result with the chromatogram of pure 2-propanol. The chromatogram of 2-propanol show a single major peak at approximately 2.7 minutes. Since the retention time closely matched the earlier peak in the standard mixture, we assign the 2.69 minute peak to 2-propanol. This also agree with its lower boiling point and higher volatility, which cause it to elute faster. Next, to identify the later peak, we compare the result with the chromatogram of pure N-butanol. The chromatogram of N-butanol show one major peak at about 6.04 minutes. This value is very close to the later peak of the standard mixture at 5.9 minutes. So the later peak is assigned to N-butanol. This is consistent with its higher boiling point and lower volatility, which lead to a longer retention time. When the column temperature increase, the analyte move faster through the column and interact less with the stationary phase. This causes a shorter retention time and make the analysis quicker. But because the compounds separate over a shorter time, peak resolution can decrease, especially for compounds that elute close together. When the column temperature is lower, the analytes travel more slowly and interact more with the stationary phase. This gives longer retention time, but it also improves peak separation and produces clearer, more distinct peaks. So, higher temperature gives faster result, while lower temperature gives better separation.
Next, I'll present to you the result and discussion for picture 4. So basically in this picture, it has two major peaks that happen. So the first one, the earlier major peak that happened at 2.27 minutes with an area of 37.19. Meanwhile, it also had a later major peak that happened at 3.29 minutes with an area of 62.79. Later on, I will explain to you why this happened. Next, the reasoning used to determine peaks in the standard mixture. So the first picture at the top is a chromatogram of 2-propanol that show a major peak at approximately 2.7 minutes. Meanwhile, at the bottom one, the picture shows the chromatogram of standard mixture that has the earlier major peak at 2.27 minutes. This peak was assigned to 2-propanol as it has a lower boiling point, and secondly, it is more volatile, which means it will elute earlier in a gas chromatography. Even though the time is different, but that is acceptable since the first one it ran at 70 Celsius. Meanwhile, at the second one, it ran at the 100 Celsius that helped the mixture to elute earlier due to the higher temperature. So next, we move on to the second picture. So the first one at the top is a chromatogram of N-butanol that show a major peak at approximately 6 minutes. Meanwhile, at the bottom one, it shows the chromatogram of standard mixture that show the later major peak at 3.29 minutes. Okay, therefore, this peak was assigned to N-butanol as it has a higher boiling point and it is less volatile. When it is less volatile, therefore it will elute later because it interacts more strongly with the stationary phase. So the same reason happened in this picture too, because the temperature is higher running at the second picture. That's why we can see the different time of the first and second picture. Okay, lastly I will present to you the column temperature versus rotation time, which stated like reasons why we see that when we increase the temperature, the rotation time also will be faster. So first, when we increase the column temperature, it will increase the kinetic energy and the volatility of analyte. And secondly, it will also reduce the interaction time between the analyte and the stationary phase due to the higher temperature. They will cause compound to elute faster, resulting in shorter retention times, like I stated before. And secondly, what will happen when we decrease the column temperature? So of course, it will decrease the analyte volatility and increase the interaction with the stationary phase and result in longer retention time and lead to slower elution of the compounds. That's why when we run at the 70 Celsius, it elute at the 6 minutes like that. Meanwhile, when we run at the 100 Celsius, they elute at the 3.29 minutes and so on. So it shows the different time when we adding the temperature up and slow down the temperature.
Moving on to our fifth result and discussion. We are looking at the result for standard mixture. The peaks in the chromatogram are influenced by the boiling point and volatility of the compound. More volatile compounds elute early, producing peaks at a shorter retention time. Compounds with higher boiling points and lower volatility elute later. In this chromatogram, which has the largest area percentage, represent the main component of the standard mixture. The smaller peak indicates a minor component present in a much lower amount. The peak reflects the relative quantity of each compound in the mixture. Now we will discuss the reasoning used to identify the specific peaks found within our standard mixture. When analyzing a mixture with multiple components, we must compare it against individual chromatograms to ensure accurate identification based on retention times. First, let's look at the identification of 2-propanol. When we run the individual chromatogram for 2-propanol, it shows a major peak at approximately 2.7 minutes. Comparing this to our standard mixture, we identify it as the earlier major peak at 1.95 minutes. We assign this peak to propanol because it has a lower boiling point and is more volatile, allowing it to move through the GC column faster than the others. We identify the second component, which is N-butanol. The individual chromatogram for N-butanol shows a major peak at approximately 6.04 minutes. In our standard mixture, this corresponds to the later major peak at 2.23 minutes. This peak was assigned to N-butanol because it has a higher boiling point. Being less volatile, it interacts more with the stationary phase, which causes it to dilute later than the lastly, the effect of reducing and increasing the column temperature on retention time and peak resolution. Reducing the column temperature increases the retention time because the analytes interact more strongly with the stationary phase and therefore move more slowly through the column. As a result, compounds, especially those with higher boiling points, dilute later. Lower temperature generally improve peak resolution because the compounds have more time to separate, although the peaks may become broader and the total analysis time is longer. In contrast, increasing the column temperature decreases the retention time by providing the analytes with more kinetic energy, allowing them to travel faster through the column. This causes the compound to elute early and shortens the analysis time. However, peak resolution may decrease at higher temperatures because compound elute too quickly and may overlap, even though the peaks are often sharper.
This experiment showed that gas chromatography can effectively separate and identify the compound in our unknown sample by comparing their retention time with propanol and butanol. We also learned how temperature affects the result. Higher temperature speed up elution, while lower temperature give better peak separation. This finding meet the objective of the study and help us understand GC in practical way. Beyond the lab, GC is widely used in real applications such as environmental testing, food analysis, and forensic work, showing how important this instrument is in many fields.